Kinetic energy is the energy possessed by a particle in motion. The greater the speed of the particle, the greater kinetic energy it has. Although I can't see the speed of an individual particle, we can measure the average kinetic energy in a substance by measuring its temperature. So if, for example, I take 2 beakers of water containing the same number of particles and measure their temperature, the beaker with the highest temperature must have the highest average kinetic energy amongst its particles. And we can actually be even more specific when talking about temperature and kinetic energy. Kinetic energy is directly proportional to the temperature as long as we're using units of Kelvin. Which means if I were to draw a graph of kinetic energy against temperature, it would look something like this. And at the start point of this graph, you could say that at 0 Kelvin, there would be 0 kinetic energy in the particles in my substance. However, we won't really see anything at 0 Kelvin, so we don't need to worry too much about that point. The concept of thermal energy is a really important concept that's related to kinetic energy. Put simply, the thermal energy in a system is the total kinetic energy of all the particles. So if I go back to my 2 beakers of water, assuming that there are the same number of molecules of water in each beaker, the beaker on the right must have greater thermal energy because it has an average kinetic energy which is much higher. However, we could apply this to a slightly more complicated example of an iceberg and a cup of tea. If we measured the temperature of the iceberg and the cup of tea, we would expect the cup of tea to have a much higher temperature. And this means that the particles in my cup of tea have a higher average kinetic energy. However, if I was asked which of these two systems contains the greater amount of thermal energy, although the particles in my cup of tea are moving much faster, I actually have a much greater number of particles in my iceberg. So even though they might have a lower average kinetic energy, when I add up the kinetic energy of all of them, I would see a greater total number, meaning that the iceberg would actually have a greater amount of thermal energy. So it's important to remember the difference between kinetic energy and thermal energy. Let's now summarize the key points from this video. Firstly, kinetic energy is the energy possessed by a particle in motion. If a particle has increasing speed, we say it has increasing kinetic energy, and vice versa. We can measure the average kinetic energy in a substance by measuring the temperature. And we might be a bit more specific here and say that kinetic energy is directly proportional to the temperature as long as it's in units of Kelvin. Finally, the related concept of thermal energy is simply the total kinetic energy of all particles in my system. And that's it. Hopefully this video is of some help.